third hour. All right, so 4H is about growth and decay, and it's expanding on the growth and decay that we talked about last chapter. So a lot of it will be very similar, though we will talk a little bit about financial growth that we didn't. Do you want to scoot over? You get to choose your own seats, right? Okay. So go ahead and get to your stat box. Yep. We're going to talk about growth and decay. So we'll talk a little bit about how we can use it, how we've used it in the past, and then our example is really going to focus on how we can use it for financial growth. So you will have problems of all sorts of different types. So just kind of a reminder that those logarithms can be used to solve problems concerning population growth, radioactive decay, and more. All that stuff we talked about in chapter 3. The thing is that in chapter 3, mostly we were given amounts of time. You know, like this substance is going to decay, how much is left after 2 years, 10 years, etc. We put in the time, we got our answer. Well, what we can do with the logarithms is that we can say, well, how much, if we have this much of that substance left, how much time has passed? Or if the population has grown to a certain number, we can figure out, okay, how many years did it take to reach that? So we can use our strategies with logarithms. There's more than one way to solve a lot of these. So one strategy to remember is you can take the log of both sides. Another strategy that I didn't write up here is that change of base that we talked about 2 days ago. So taking the log of both sides and change of base will be things you'll think about as you are going through and solving your questions today. Like I said, you're using those skills you've already learned. We are going to talk about the financial growth, which is new, but after we set that up, we're using skills we already have. So here is some stuff for financial growth. So do you guys know what that means? What does financial growth mean? An investment, like investing money. So if an initial amount is invested at a fixed rate for each compounding period, the value of the investment after n periods is given by this formula. U sub n plus 1 equals U sub 1 times r to the nth power. And we'll talk about all the different parts of this formula as well. We're going to have a lot of formulas that are really similar to this in chapter 6, so it's kind of a nice little introduction, getting our feet wet with this formula as we work on it today. U sub 1 is our initial amount. So it might be dollars, might be pounds, might be yen, might be something else, because we do have an international textbook. But whatever it is, it's money. It's the initial amount of money that you put in the bank. Whether it's $2 or $1,000 or $1 million, it's the amount of money you start with. It's a subscript. So do you guys remember, like, when you do slope back in Algebra 1 and you have, like, y2 minus y1, x2 minus x1? It's just a subscript. And the 1 just stands for, like, that's the first amount of money we have. Like, that's what we have to start with. And I don't know why they chose U, but they use U. We're going to use that U sub 1 a lot when we get to chapter 6, so you'll get used to it after that. The N is time periods. Most often it's years. So the amount of years that you have that money in the bank for. R is the rate, like the interest rate. We do have to talk more about R. On the next slide, I'm going to get in depth about how we figure out our R, because we can't just plug in the percent. Does anyone have money in like a savings account or something that's like earning interest and know how much it is? I never remember either. It's usually pretty small, but like if you're earning 1% interest or something, I can't just plug in 1%. I have to change that percent to a decimal. So we'll talk more about that on the next slide. And then use of n plus 1 is like the ending amount of money. So you pretty much will have two different situations. You will have some questions where it says, how much money will you have after 10 years? And you plug in 10 for n and you figure out how much money that is. Or you might have questions that say, okay, you're going to start with $1,000. How long will it take you to end up with $10,000? And then you have to find the time. So those are sort of the two different questions that we'll have, types of questions. We are going to talk about that rate a little bit more up next. Are there any questions? Okay. So here's the deal with the rate. It must be changed from a percent to a decimal, number one. Number two, and this one is a little weird and it can kind of take a little bit of time to wrap our minds around, but we want to include the initial investment when we find our amount, right? So because we want to include in the initial investment amount, we have to add 1 to it. If I don't add the 1, it won't include the part we started with. If I just leave it as a decimal, I'm only going to get the interest, and then I would have to take another step and add the interest to the initial amount myself. So by adding 1 to it, what happens is it counts the first amount with it. So that we're going to do an example of just calculating our rate without a full problem up next. Again, I know it takes a little while to kind of think about, but are there other questions about that? Those of you guys that have headphones on, are you listening to music, or are they just like really comfy? Okay, I hope not, because you really should try not to multitask during this. So first we're going to change this percent to a decimal. So 4.66%. How do I move my decimal point to make it a decimal? Which way? To the left twice, because it's out of 100. So I would have 0.0466. So I moved it over 2 times, so I had to add in a 0. Now if I left it like that, I would only calculate interest, and I wouldn't also include the initial amount. Well, I want to make less work for myself, so if I add 1 to it and get 1.46 or 1.0466, that will allow me to get all of the money. It'll tell me like, okay, what you had plus what you earned together. So it's less steps, less work for us. We're going to do an example with this financial growth. Is there any questions or confusion going on? So here is our example. I will write the formula up. The example is that Jerome is investing $5,000 into an account that pays 2.5% interest annually. How long will it take for his money to double? So I'm just going to write the formula down. Now, some of you guys might have your own techniques for how you get ready to like set everything up. One thing that I like to do is kind of off to the side, write down everything that's in my formula and then make sure I know where it goes. So I've got u sub n plus 1, u sub 1, r, and n. So u sub n plus 1 is my initial amount. So I'm investing 5,000. And if I kind of take that step, then I make sure I have like everything in the right spots. And we'll talk more about this when we use more of these formulas in chapter 6, but for right now, kind of get us ready. Now my rate is 2.5%, but remember I have to move the decimal place twice and add the 1. So it's 1.025 for the rate. N stands for time. Do I know the amount of time that I'm investing? Nope, so that's what I'll be looking for. And then the u sub n plus 1, that's the amount of money we end up with. How much money do we want to end up with?
10,000.
How did you guys get 10,000?
5,000 times 2.
Beautiful. We have to take the 5,000 times 2 because we're doubling it. So taking the step will help you make sure that everything is in the right spots. Some of you might not need it, but it's just one strategy that works for me so I can like help keep everything organized. Because now we can substitute all of these numbers in. So I've got 10,000 equals 5,000 times the 1.025 to the n power. So it kind of helps. I see all those different things, pick them out from the problem, and then I put them where they need to go. When you see that you have a variable that's an exponent, that's kind of a signal that you're probably going to have to use logarithms to solve it. So we have to, first of all, kind of get that power, this power expression right here by itself. So how can I get rid of the 5,000? Divide that out. So I end up with 2 equals 1.025 to the n power. Here is where you have options. There is more than one way to solve this with logarithms. Anyone have any idea? Or any thoughts where they want to go with it? Expand on it. You can do log on both sides. So I could go like this, and I could do log of 2 equals log of 1.025 to the n. And I've got to get the n by itself. Right now it's still in that exponent, but what can I do with it? Kind of beautiful. We can put that in front. So log of 2 equals n times log of 1.025. Yep. Then I can divide by that log. So I'll have to use my calculator, but n equals the log of 2 divided by the log of 1.025. So we'll have to estimate that. So go ahead and calculate that on your calculator. How much time would it take us to get up to $10,000? What did you guys get? So 28.07, so about 28 or 28.1 years. So just over 28 years. Can you guys believe that? I would have had to make that investment when I was like 3 years old to make $10,000 and not take anything out. It's a long time, right?
You didn't make $10,000.
What?
You only made $5,000.
But like I would have $10,000. I don't know. Just real quickly, if that way, did everyone get this? Okay, so if that way wasn't really your thing, the other way you could do it is you could use Ben and Benny. So this is Ben base exponent number. I could change it to log base 1.025 of 2 equals n. And then I know yesterday we talked about how some of our fancy graphing calculators have the alternate bases. But if you have just like a regular calculator, you've got to use base 10. So then I would have to use change of base. So if I use change of base, remember this goes on top. And hopefully you guys see that we end up with the same exact thing, right? So whichever method you use, by log on both sides or using change of base, is really up to you. So we're just going to stop at the stat box, which is a little bit lame today. But then that's it. So what you need to remember, it's kind of a lot, but anything that's kind of sticking out at you is like, okay, I really got to remember to do that or think about this or anything.
Add the one.
Add the ones that rate. Gotta remember the formula. I'm pretty sure it's not in your packet. Gotta remember your different options for solving. So again, kind of getting in touch to the methods that work for you. Like I said, it is kind of a lot. Okay. Here is our practice assignment then for 4H.